Let's look at question 22. Generate parentheses. So we give the integer n and then generate all the possible well-formed parentheses. What means for the well-formed parentheses? It means you have open parentheses, you have close one to match it. So let us analyze this question. This is a special combination question. So if you have open one, you must have the closed one. So this is for n1. If n is 2, so you can have 2 open one and 2 close one, or you can have 1 open, 1 close, 1 open, 1 close. So this is a two possible option for this well-formed parentheses. If n is 3, what is the strategy? We to build all the well-formed parentheses. So first, we give the as much as possible open one, and then we close it. Then we move one open one to here. So it's this one, and we close it. And then we have open one, close, close. Then other one is we move this open one. So it's open one, close, open one, and now we can give as much as possible open one and close, close. Then we can move this one to the right. So it's open one, close one, open one, close one, open one, close one. So the strategy is we have to give the open one first, and then we give the closed one, and then we try to move the open one to the right. This is a strategy. Okay, let us start coding and to see how we can write this code. So for that one, normally we will use recursive to finish it. So let us define the recursive function. So we can use private, and this will be the no return. So this is this one, and so in the beginning, the first parameter we have to give the list. So in this recursive, we use this parameter to save the result, and then we give the max. Actually, this is n, and we give the open one. How many open one we already have, and we give the close one. And also we need to use some string builder to hold the final will forward parentheses. Okay, this is we give the definition for the recursive function. Then we start to call this one. So at the beginning, we have to define the return value. This one is a general array list. Yeah, and then we need to return it, right? And then we start to call this recursive function. So recursive function, first parameter is a return list. Second one is n, and in the beginning, the open one is 0, close one is 0, and we have a new string buffer object. Okay, and then now we need to build this string buffer. So if open one, so we have give the open one as much as possible. So if n open one less than n, what we should do is in the buffer string builder, it should give the hint. No, string builder. So they should have the append function. So the left one. Okay, and then if we build this one, we call the recursive function again. So here and the max, and now open one, we already have one open, right? And then we have same close and the buffer. After this function finished, we need to remove this one we added. So this one will be what happened? So string builder will be the general one. The LeetCode should support this one. This will be the string builder. String builder, I think I try this one. Why? String builder, is any typo here? Try this one, this one, wider. Any typo here? String. Oh, I think we have this one, because this definition is wrong, so they cannot give us the hint. Okay. Then we need to delete the last one. So the last one is so we need to delete it. Okay, and then so we already have the open one. If the close one, so what happened for in the beginning? For example, we have n is 3, so we come here, we add 1 and call again, add 1 and add 1. So we have 3 open now. Then we need to add the close one. So close. So here is, remember, close one should less than open. Otherwise, you cannot match it. So buffer will append close one. I think if we give this I think it will be better. The child maybe have little performance improve. And then if we build the close one, we will call this recursive function again. Let it continue build the next level. Same thing to remove this one. Okay, so when this function find the perfect match, so we have to here. So if buffer's line is equal to max times 2, this means we get enough close and open. So here we will add one result and return it. So let us use the n equals 3 to test this one. So here, I will write here. So in the first 3 round, they will reach this one. So they get left, okay, left, right? Because come here, they continue recursive this one, and then when open is 3, they will reach this one. Okay, after reach this one, the first round is the first close, second round is second close. They continue in this recursive, and then come here. When this is running, they reach this one. They add this string to the return list. Then, okay, they go back here and do this one, right? Because the last 3 will reach this recursive. So then we get a 3 return. They will made we already remove 3 line here, right? We remove the last one. Then they return to here. Then they remove the left one, right? So it's then they will return here. When this return, this one happen. Because this return to here and remove this one, then they will go into this function because this if is not returned, so they will reach this one, right? In here, close already reset to the 0, so then we get one close right here, and then they call here. They call this recursive. This recursive will cause this and they will go into this one. And this one will call this one and add the one close here, and then continue add close here. So the second one, we get this will form the parentheses. Then we continue remove this 2, remove this 1, then remove this 2. So we will finally build this one. and then we build this one. So we get all four will form the parentheses. So let's run the code. Okay, out here should be the max. Okay, so you see we get the result and then submit the code. Okay, the performance also is very good. Thank you for watching this video.